Welcome to In 5 Minutes. The agenda of this clip is to understand an SR Latch NOR based, and we'll be using this to implement my SR Latch in the static CMOS style. Remember, first we are going to study the NOR based design, then we'll study the NAND based design. On your screen you can see an SR Latch using NOR gates. We have already studied this in our previous classes, and we also see the truth table below it. I'm not going into the nitty-gritties of explaining you the truth table. It only shows that when my S is 0 and my R is 0, it will hold the previous value. When S is 1, irrespective of R, the output will be set to 1. When R is 1, irrespective of my S, my output will be set to 0. And when both are 1, we know that when S is 1 and R is 1, and both this being the input to a NOR gate, if any one of the input to the NOR gate is 1, the output is 0. So here both my output and its complement is equal to 0, but we very well know that that's not possible and that's not allowed, and this condition is nothing but the race condition. We have seen all this in our previous class. Right now the idea is to implement this in static CMOS style. So let's quickly do that. In the previous clip, we have already seen how to implement a NOR using transistors in static CMOS style. We hide the bar. Whatever is below the bar is nothing but my pull down network. So here we have A and B in parallel, and pull down is nothing but NMOS. So we have NMOS transistors in parallel for NOR, and the complement of it, nothing but the series connection of PMOS, is nothing but my pull-up network A and B, and this is nothing but my output V out. So we have already seen this. This is nothing but a NOR implementation. Here we see that there are two NORs, NOR 1 and NOR 2, and we will be implementing both these NORs and make the connection, and that's nothing but the implementation of SR Latch in NOR style, or I could say implementation of SR Latch in static CMOS style using the concept of NORs. Okay, let's quickly do that. So let's make our two NOR circuits. As we said, this is NOR 1, this is NOR 2. So we have NMOS connected in parallel to each other. We'll give the inputs later. Let's first just connect, and this is my PMOS in series, VDD, and this is going to be my output. Let's make the another NOR real quick. We have already seen how to do this. This is my VDD, ground, ground. Okay, let's say this is NOR 1, this is NOR 2. Now let's see the connections. So NOR 1 has one input as S, so let's do that. This is input S, another input as Q, so this is Q, so S and Q. NOR 2 has one input as R, another input as Q bar, so let's mention that, R and Q bar. NOR 1 output is nothing but Q bar, so this is Q bar. Remember, wherever there is Q bar, they are all internally shorted, so this Q bar is shorted to this internally, and same is the case here as well. And NOR 2 has an output which is nothing but Q, so this is nothing but Q, and this Q is shorted internally to this input and to this input as well. This is nothing but my SR Latch implementation in static style using the concept of NOR. In the further clip, we will see how to implement the SR Latch using the concept of NAND in static CMOS style, and the diagram which you can see on the screen, you can verify this is to be correct by implementing or by inserting different values of S and R from the truth table, and you'll identify that the functionality is achieved. Hope you have understood. Stay tuned for further clips, and thank you very much.